What port should I use?
Brad, do you have the adapter? I think we're going to...
Oh, yeah, I've got the adapter if you need it.
I can probably give like a short introduction while the ports, or while the adapters get in here. I'm Brian. I work for a company called Full Stack. I guess we're full stack developers. So, yeah. And this talk's going to be mostly about API design, not so much about Rails or Ruby specifically. But it's going to show off some of the Ruby and Rails ecosystem around like why Rails is a pretty good fit for building APIs, specifically HTTP APIs, not like, I don't know, anything else. Hang on a second. Did anyone who know Keynote very well, can you come up and help me for a second? I know APIs, but I don't know Keynote.
I used it once.
Yeah.
But I was for presentation.
So I just want to get the presenter notes.
The notes?
Yeah.
Okay. So we'll do that. No, wrong way. And,
So you can do like,
I think...
oh, cool, okay. Yeah.
Good?
No, then you'll cheat. Alright. Cool. Thank you, Brad. Yeah, so HTTP and stuff. That's what I'm going to be talking about. And so, yeah, the premise of this talk is that any API method has certain characteristics about it. That's kind of a hand-wavy statement I'll make concrete later. And I think that it's easier to develop against an API if those kind of hand-wavy characteristics are made explicit instead of implicit. And what this talk goes into is a couple ways to make those things explicit, either by putting them in the transport mechanism, which is HTTP, or by putting them in the messages that you're sending back and forth, and that'll get into a concept called hypermedia. So this is a very small API, maybe the smallest possible API that returns anything. Shows off Sinatra's legendary terseness. And there may be like 5 important parts of this, most of which I'll end up talking about at some point. So we've got an HTTP method, we've got a response code, response headers, and the body. And this is like the first step into thinking about hypermedia. But before that, I want to talk about all the glorious wonders of HTTP, because it's a very rich and expressive protocol that I took for granted for a long time. And I think it's helpful to know all the ways that you can use it to communicate with your clients. So you're probably familiar with these verbs, right? There are more verbs in HTTP, and actually patch isn't technically part of the spec, but these are the ones that I end up returning to again and again. And people talk about them in a lot of different ways, but what I want to focus on today is making safety explicit. So get, for instance, is safe. I mean, you can do whatever you want as somebody implementing a server. You can do whatever you want in a GET request. But when a client issues a GET, they expect the result to be pretty much read-only. So maybe it like tracks your GET request, but no state on the server should change. It shouldn't have side effects. And that's like the strongest guarantee that a client has. GET is also considered idempotent because it doesn't do anything. So are put and delete So idempotency, if you're not familiar, is like the idea of this action. Basically, in practice, it means that you can just repeat puts and deletes over and over again, and you should expect the same state on the server as a result. And that's another useful thing to communicate to a client. So if your client is like a human, they can do a lot of like intelligent error correction for things like unsafe operations like posts and patches. But for automated processes, like network failure means that they don't necessarily know if their unsafe operation succeeded. So if you allow them to do puts and deletes, they can just hammer that endpoint until they're confident that their operation succeeded, and they can be confident that it had the ideal result. I just ran into a good example of put and delete that I'd like to share. Trying to come up with examples of these things. So a good use case for put might be if you're following somebody on Twitter. Let's say your JavaScript is disabled and you click the follow button. Ordinarily, it would update automatically to say, well, now you can unfollow this person. But in a world where you've just sent off a put request and you don't know the result, you could click it any number of times, and ultimately you should be following the person. And even if you try to refollow them, it shouldn't cause an error. Likewise, when you unfollow them, like you should be able to try to unfollow them any number of times. And even if the first time succeeded, all subsequent times should be kosher. So post and patch are unsafe. Again, human clients should know this when they're writing machine clients, so they can be careful with these methods. Because you don't necessarily want to like be retrying these methods in some sort of loop. It's helpful to have intervention when these things fail. So making safety explicit is important from the client side when they're talking to the server, but when they get a response, they don't necessarily care about safety anymore. They want to know like what happened. And so we can use things like status codes to make success and failure obvious. Maybe not at a domain-specific layer, or domain-specific level. But at a high level, we can determine if what we did worked, and we can build logic around that sort of did it succeed, did it fail, and then who failed. So validation errors you'll often see as 400s or 422s. If you forgot to run a database migration in Rails, for instance, you'll probably see a 500. That's a server error. And then there's nuance too. Like if something succeeds and it ended up creating a resource, you can communicate that. So you can build up generic libraries around these very fundamental concepts of APIs without having to know anything about a domain. So HTTP also has ways to save bandwidth. And when I was writing this slide, I thought of the sort of meme, use this doctor or ISPs hate him, use this one weird trick to save lots of bandwidth. Because you can tell the server in a pretty short amount of characters, only send me stuff if I haven't already seen it. So in this case, we'd already curled example.com. They had sent back an e tag, which was this value, and we stored the response along with the e tag, and then the next time we request it, we say, well, only send me back the response if it doesn't match this e tag. And if example.com hasn't changed, it sent back a 304 with nothing. And then we would know, well, we don't have to process anything, we're all good. And there are similar headers for doing this sort of comparison based on dates, based on partial content matches. It's a pretty wide array of techniques you can use to save processing and bandwidth. And there's also a way to indicate that you can read certain types of encoding. So often you'll see gzip encoding done at like the web server layer as an Nginx module, for instance. So even if you do have some sort of cache miss, if you and the server both speak gzip, then you can save lots and lots of space. So there's also a way to agree on what language you're talking to each other at the message level. So you'll see this commonly as something like an accept header. Rails also has a convention of appending like magical parameters to URLs, but this is my preferred way of indicating that we should both speak this application/vnd.example plus JSON version 1 language to each other. And clients and servers can negotiate these things. So in this case, maybe example.com doesn't speak this, but it offers me JSON instead. And I can still process that, but it might not be in the exact format I want. That use case is a little bit contrived and like in practice kind of breaks a lot of stuff. But what's really interesting about this is the version parameter. It's a nice way to keep URLs consistent between API versions and to have clients indicate which version of the API they speak based on this header. So that covers like a lot of that small code snippet, and I kind of breezed through a bunch of it. So are there any questions so far? Cool. So this, okay, so this gets us into Hypermedia. And if HTTP is this like domain agnostic, nice set of ways to communicate with a client, Hypermedia is usually some sort of domain-specific format, for lack of a better term, which communicates like what is actually going on in the application. Hypermedia lets your clients be pretty stable, ideally. It does that because a Hypermedia payload is complete, so you can look at the entire payload and know what all the data is inside of it. You probably have some metadata about that data. So for instance, actually field names is kind of a silly example of metadata. If you have like a field name and field value scheme, that's metadata. But then it also has information about like what you can do to the application from this point. And those are typically called affordances. So this is an example of something which is not really a Hypermedia payload. And it could mean anything, I think. So we have Apache 2 and apt, and it looks like we might have some IDs, and then like a timestamp. But just by looking at this, it's without any other code, it's kind of impossible to know what this is. And we can add a little bit of metadata to it. So now we know that we're dealing with cookbooks. So this is like maybe a chef API. And yeah, we do have an ID. We have the name of a cookbook, and we have when the cookbook was last modified. But we still don't know what we can do with this data. So we had links. This is a convention, I think, from the HAL standard. But the idea is that now I know what I can do with the Apache 2 cookbook. And I know what I can, and actually, from looking at the Apache 2 cookbook, I know that I can't unshare the apt cookbook. And then at the highest level, I know that I can share another cookbook, I can requery the list of cookbooks, and I can search cookbooks using this URL template. And this is actually sort of loosely taken from a project that I'm working on right now. So I can say for sure that this is not completely baked. But it's getting there. And part of this process is like iterating on the design and working with the consumers of your API to figure out if it's satisfying their needs. Because like that's the whole point of this, is like we want to enable clients to get stuff done, and we want them to like feel reasonably confident that they're not going to break in 6 months without any code changes. So yeah, so there's some great things about this. It's easy to look at it and know like what's possible, to know what the data is. There are also some downsides in that it's considerably larger than this. And, I mean, for a payload with as little information as this, it could be even smaller. But I would make a maybe wild claim that you probably don't care about the payload size that much at first, and there are things that you can do to make it smaller if you need to. So this leads into this concept of Hadios, the breakfast cereal of REST aficionados. It stands for Hypermedia as the engine of application state. And that's just kind of a long way to say what's going on here. Like, the Hypermedia response here tells us what state we're in. You could maybe derive this from a state machine. Which actually is like, that's how you get to this point. You identify, what am I trying to do as a client of this API, and what are the possible states of the application, and then you start kind of playing with that to get a response. And that's pretty much all I have to say on Hypermedia. It is definitely a lot more difficult, or not difficult, but it's a lot more time consuming to reach a point where you're happy with any sort of response. The response up there is, like I said, not complete. And so Hypermedia is as much about state machines as it is about revision. But that revision for us happens in Ruby and on Rails, and so this is kind of like the next abrupt segue into something completely unrelated to theory. This is all about the practice of making this happen. Yeah, you bet.
So with the links section, I'm not sure if you guys control your API clients or not, but do you have experience with, like, I mean, the idea is that you could change one of those links, right, and the clients would break.
Right.
Do you have experience with them? Do they actually use those links, or are they just hard to put them into the client?
Yeah, so that's a good question. So I have had great experience with people using the links, and I've had experiences where people do not use the links at all, which totally defeats the purpose, right? And I guess that's the big caveat with all this, is that you can't really trust your clients, even if you control them completely, because like you're going to make a mistake. And if you don't control the clients, then somebody else is going to make a mistake or just not realize that they're supposed to be doing things in a certain way.
I guess you can put a random string into the URL.
Just to break it, yeah. Well, so as a brief anecdote, GitHub recently, so they use a lot of these concepts in their API, and they're in the process of upgrading it. And so they did something where for a 24-hour period, their default response changed from their current like legacy-ish API to their brand new API just to see what would break. And if you're building a platform, that might be the only way to go to figure out, like, well, how many people are actually using this? Like, do we start to see in our server logs, like, tons and tons of 500s or 404s? Does that answer your question? Okay. Right. So building these APIs in Ruby and on Rails, there's some benefits to doing it in Rails, especially if you don't feel like writing a lot of kind of plumbing code, because for Rails has a good router, which means that on the server side you don't have to do a whole lot of link munging either. It has good support for HTTP methods and response codes. It has good support for like custom MIME types or hypermedia types. It automatically generates E tags for your responses, so you get that if none match stuff pretty much for free. And it also has like some other built-in HTTP caching control stuff. So yeah, so like I said, I'm working on this project called the Chef Supermarket. It's sort of like the Ruby gems of chef cookbooks, and the next few things are going to be using this as an example. So when you're thinking about this, think like package manager. And I think it's actually a pretty good example, especially for like real world stuff, because it's an existing API, but we want to make it better, and we want to introduce some of these concepts to it. So we're forced to deal with like the realities of having this legacy API while also wanting to like move forward past it. And there are some good tools to make that happen. So yeah, like I said, this works right now on the existing site with the free E tags, and this is what the API surface area looks like right now. So if you're not familiar with Rails, this hooks up all the URLs and controllers, and then also gives us helper methods throughout our app to generate like strings. And this is right now the closest thing we have to like Hypermedia, in that all the errors are consistent, which is actually super important to have consistently formatted errors. But yeah, we'd like to do a bit better. So we'd like to get towards like domain specificity. That error was not very domain specific and was kind of redundant. And we'd like to expose more of the API through the API. So if you go back to the routes, so we have the initial index, we have a search endpoint, you can view a single cookbook, you can view a single version of a cookbook, you can upload cookbooks, and you can delete cookbooks. But only about half of this is visible through any given API response. Sorry, I just saw your hand.
Yeah. So for the error messages, you return like a 404, and then in the response body, you put that formatted response.
Right. Yeah. So that's the nice like separation between like application agnostic errors like 404, 400, and then in your messages you can get more specific, like your cookbook doesn't have a name, or you're missing like the tarball that contains the artifact. In that case, it would have been helpful to know that like the MadRailers cookbook was missing, and not just, oh, we couldn't find something. And actually, that's one strength I'll say of Rails, is that its active record style errors are pretty well suited to building API clients around things like highlighting invalid form fields, or just showing like generic stuff went wrong messages. Right. So this is my new favorite gem. It's called API versions. And I just started messing around with it to do this, which allows, it allows me to separate or insert a seam into the API to start iterating on this new media type. So all old requests will go to this bottom routing block, but requests which specify this new, which say that they speak this new media type, will go to the upper routing block. And to start, I can just like route all the new stuff to the old controllers, but as we start to build out like new clients, new functionality based on the API, we can start to put it in this new routing scope, and we get all the benefits of Rails routes, but it's all automatically routed to our new stuff. And yeah, I think that's very cool. And so now we've been routed, and now we want to start thinking about view templates. And I thought it'd be good to talk about the myriad ways that you can generate JSON or XML or anything in Ruby. This is just kind of trying to show off the Ruby ecosystem around generating templates. So this is JBuilder. JBuilder is, I believe it now, comes in the Rails gem file, and it's very simple and straightforward. And you can get a lot of mileage out of JBuilder, and it's especially helpful for understanding at a very hands-on level what some of this hypermedia stuff might look like. And so I recommend giving it a shot. On the other end of the spectrum, you have this very concise active model serializer, which is part of the Rails API project, which is pretty cool. It's like a fork of Rails that cuts out a bunch of stuff that you probably don't need for an API. And yeah, this would actually be a completely different response than what I just showed, but the idea is that you treat your serializer like you would treat your models. And it's the project is kind of in flux right now, but it seems like this could become the de facto way to serialize stuff to JSON in Rails. It's very Railsy. There's also this project called Roar. Roar is a little bit like active model serializers, but it's one of the selling points of it is that you're just sort of defining a schema, and then you let Roar represent your stuff as either JSON or XML or whatever. And it has better support than active model serializers for things like inserting links, which is a pretty crucial part of Hypermedia. And yeah, then there's this other project called Rabble. And I haven't used Rabble a whole lot, but it's a little bit more like JBuilder. Yeah, more of a hybrid between JBuilder and active model serializer. And then the final template serializer library that I've played around with is Oat. And I think that if I were to convert something from JBuilder to something else, I'd probably give Oat a try. It's the same idea of having schemas, but it's got support for JSON API, which is really cool. And yeah, it kind of maps to how my brain works. I also wanted to call out that Ruby's got a good library for doing URL templates. So this is a way to find middle ground between having a complete URL specified in your response and allowing clients to specify parameters. So in this case, an iOS app could expand some text in a search bar to the queue parameter and then send a GET request to that to execute a search. But in any case, the templates and stuff, I think it's awesome that there's so much activity in the Ruby community around trying to figure out better ways to do this. But